Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is M.Zafri based in M.Zafri. Today, my group will talk about the Dynamo effect from chapter 30 Faraday law. So the first thing we need to know, what is the Dynamo effect? The term Dynamo effect is commonly used in the context of electrical machines, particularly in relation to commutator rings. The Dynamo effect refers to the phenomenon where rotating magnetic field induces an electric current in the conductor, resulting in the generation of electrical power, like this.
Now, there is one split ring commutator. This is a dynamo, and so induces a direct current.
In a commutator ring, which is a component found in direct current, electric motors and generators, the dynamo effect is crucial for the conversion of mechanical energy into electrical energy or vice versa. The commutator consists of a set of compared segments or bars that are connected to the rotor windings of the machine. When the rotor, which carries the windings, rotates within a magnetic field, the magnetic lines of force cut across the conductor segments of the commutator. This relative motion induces an electromotive force, EMF, or voltage in the conductor segments. Due to the split ring arrangement of the commutator, the polarity of the induced voltage in each segment changes as the rotor rotates. In summary, the dynamo effect in commutator ring is the process by which a rotating magnetic field induces voltage and current in the conductor segments of a commutator, enabling the conversion of a mechanical energy into electrical energy or vice versa in the DC machines. Thank you very much. Now my friend will continue.
My name is Shah, and now I'm going to talk about how the dynamo works. Okay, so a dynamo is an electrical device that converts mechanical energy into electrical energy. It operates based on the principle of electromagnetic induction. There are 7 key points in how the dynamo works. Firstly, magnetic field. A dynamo consists of a stationary part called stator and a rotating part called the rotor. The stator contains a set of permanent magnets or electromagnets that create a static magnetic field. Second, rotating coil. The rotor consists of a coil of wire wound around an iron core. This coil is connected to a commutator, which is a segmented metal ring. As the rotor rotates, the coil moves through the magnetic field created by the rotor. Okay, thirdly, electromagnetic induction. As the coil cuts through the magnetic flux, a changing magnetic flux is produced. According to Faraday's law of electromagnetic induction, this changing magnetic flux induces an electromotive force or voltage in the coil. Fourth, the commutator and brushes. The commutator plays a crucial role in a dynamo. It consists of a segment that are connected to the ends of the coil. The brushes, usually made of carbon, are in contact with the commutator segments. The brushes provide an electrical connection to the external circuit. Fifth, current generation. As the coil rotates, the commutator and brushes ensure that the direction of the current in the coil reverses every half turn. This reversal of current direction is necessary to maintain a unidirectional flow of electricity. The commutator segments ensure that the coil is connected to the external circuit in such a way that the induced current flows in one direction. 6. Electrical current. The induced current flows through the coil and the external circuit, generating electrical power. This power can be used to operate various devices or can be stored in batteries for later use. In summary, a dynamo works by rotating a coil of wire within a magnetic field, which induces an electric current in the coil through electromagnetic induction. The use of a commutator and the brushes ensures that the induced current flows in one direction, allowing the conversion of mechanical energy into electrical energy. And that's all for me. Moving on to my friends. Thank you so much.
Assalamualaikum warahmatullahi wabarakatuh. My name is M.Nazhim. I'm going to talk about how dynamo invented. The Faraday disc, invented by Michael Faraday in the early 1830s, was the first electric generator. It consists of a copper disc rotating between the poles of a horseshoe magnet. As the disc turned, it induced an electric current radially outward from the center to the rim. However, this design was inefficient due to the counterflows of current and low voltage output. Hippolyte PC built the first commutated dynamo in 1832, which used a rotating magnet to induce current in the coil. PC invented the commutator to convert the alternating current to direct current, DC. Antonio Pessinotti improved dynamo designs in 1860 by using a multiple toroidal coil which smoothed out the current and increased efficiency. The first practical dynamo for industrial use were independently developed by Sir Charles Wheatstone, Werner von Siemens and Samuel Alfred Varley in the mid-19th century. They used electromagnet instead of permanent magnet to generate a stronger magnetic field, leading a higher power output. Zenobie Graham reinvented Pessinotti design in 1871, creating the Graham dynamo that generate commercial quantities of power for industry. The dynamo design involved further with Charles F. Brush, shaping the armature like a disc and positioning the field electromagnets on the side, improving efficiency. Rotary converters were developed to convert between different types of electric current, but they were later replaced by solid-state power semiconductor device. Direct current machines, such as dynamos, have limitation including higher maintenance costs, power limitation, and inefficiency due to the commutator. Alternating current AC machine without commutator became more popular for their efficiency and ability to distribute power over long distance. With the widespread adoption of alternating current in the 20th century, dynamo were replaced by the alternator and become almost obsolete.
Assalamualaikum warahmatullahi wabarakatuh. My name is M.Yazid bin M.Shazwan and I will talk about where is dynamo used at. So, dynamo machines are often found in various applications. So, the first example is the most common example of dynamo, which is bicycle dynamo. Dynamo in a bicycle is a device typically located in the hub of a bike's wheel that converts the energy generated by the wheel spinning to electrical energy. That power is then used to run front and rear dynamo lights on the bike, providing always-on illumination without the need to charge the lights. Other than that example is electric vehicles. Dynamos, also known as generators or alternators, are used in electric and hybrid vehicles to convert mechanical energy from the engine or braking system into electrical energy. This electrical energy is used to charge the vehicle's battery or power the electric motors. So the next example is power generation. Large-scale dynamos are used in power plants to convert mechanical energy, typically from steam turbines or water turbines, into electrical energy. These dynamos generate the electricity that is supplied to homes, businesses, and industries. So the last example is magnetohydrodynamics. Dynamos are crucial in the field of magnetohydrodynamics, which studies the behavior of electrically conducting fluids in the presence of magnetic fields. Dynamos are used in investigating phenomena such as the generation of magnetic fields in celestial bodies, plasma confinement in fusion reactors, and the behavior of conducting fluids in astrophysics. So in summary of what I've just said just now, dynamos play a significant role in power generation, electric vehicles, laboratory experiments, and the study of magnetohydrodynamics. Thank you.
Okay, now that's the end of our discussion today. I hope what we discussed just now able to make you, the audience, understand better about Dynamo. That's all from my group. And bye bye. See you soon. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is M.Yazid bin M.Shazwan.
So I hope our group really make you understand. That's all from now.
Okay, that's all from us. I hope what we discussed just now can make you understand more about dynamos. Lepas tu, korang masuk bila? Thank you, that's all.
Yelah.